Hi students, in this video we are going to discuss about atmospheric refraction. Point number 1, atmospheric refraction. Dear students, in this video we have to discuss so many important points one by one side heading. However, at first our concept is atmospheric refraction. Before going to discuss about the atmospheric refraction, before going to discuss about the atmosphere of refraction, first we have to remember some important points. Now consider it is Earth. This is Earth. Here there is a first layer. This layer is up to 20 kilometers. So this layer we also called as a troposphere. This layer we also called as troposphere. And second, there is another layer. This layer is approximately equal to 50 kilometers. This layer we called as a stratosphere. Stratosphere. Now there is another layer here that is approximately equal to 85 kilometers. So this layer from here to here we called as mesosphere. Now the fourth one, there is another layer on the atmosphere that is approximately equal to 690 kilometers. 690 kilometers. That is we can call as thermosphere. Thermosphere. There is another layer here that is up to 10,000 kilometers. 10,000 kilometers. That one we can call as exosphere. Exosphere. My dear students, this is 20 kilometers troposphere. My dear students, please remember how many layers or how many atmospheres we are noted down here. 1, 2, 3, 4, 5. These 5 are the we are noted down here. Here the refractive while coming downward direction, density is more. Density while coming downward direction, density comma refractive index is more. Refractive index is more. This point at first we have to remember. Then only we can enter into the what is the atmosphere refraction. Okay. Now once again I am explaining. Coming from 10,000 kilometer, that means exosphere, to coming downward direction up to 20 kilometers or 0 kilometers called troposphere, the density of air is increasing. The density of air is increasing means that the refractive index is more. That means light velocity is less. Now, here atmospheric refraction. Atmospheric refraction. Atmospheric refraction is the phenomena phenomena of phenomena of bending of light. Bending of light. Bending of light on passing through. On passing. On passing through. On passing through Earth atmosphere. Earth atmosphere. Once again, I am repeating this point, my dear students. Atmospheric refraction is the phenomena of bending of light on passing through the Earth atmosphere. Okay. Now, what is Earth atmosphere? I already explained. There are 5 different layers are there from 0 to 10,000. Now, go to the second point. We move above the surface of Earth. We move above the surface of Earth. We move above the surface of Earth. Density of air. Density of air goes on decreasing. Goes on decreasing. And next point, upper layers of upper layers of Earth atmosphere. Earth atmosphere Earth atmosphere or rarer compared to the lower layers of Earth atmosphere. Earth atmosphere. Full stop. Now, local condition. Local condition Next point, local condition. Local conditions like temperature, comma, density, also affect the optical density, affect the optical density, of earth, of earth's atmosphere, of earth atmosphere. Therefore, once again, my students, once again I would like to repeat these 4 points. Point number 1, atmospheric refraction is the phenomena of bending of light on passing through earth atmosphere. Now we move above the surface of earth, density of air goes on decreasing. Full stop. Next, upper layer of the earth atmosphere are rarer compared to the lower layer of the earth atmosphere. We already know. As a result, point number 4, local conditions like temperature, density, air also affect the optical density of the earth atmosphere. Okay, now we are going to discuss point number 5. Next point, light coming from light coming from stars and entering at the atmosphere entering earth atmosphere, earth atmosphere passes from rarer to denser layers, rarer to denser layers, Next, therefore it suffers. Next point, it suffers multiple refractions. Multiple refractions before reaching the before reaching the surface of the earth. Surface of earth. This is called atmospheric refraction. Atmospheric refraction. This is called atmospheric refraction. Once again, I would like to repeat the point number 5. Light coming from the star and enter Earth atmosphere passes from rarer to denser layers. It suffers multiple, this is point number 6. It suffers multiple refractions before reaching the surface of the earth. Full stop. So this is called atmospheric refraction. Now what is our heading? Our heading is what is atmospheric refraction. So all these are the 6 points support the what is atmospheric refraction. Okay. Now I would like to draw another diagram to make you understand easily. Please draw that diagram also. My dear students, now here I draw a diagram to make you understand easily. Now consider it is an earth. From this is the surface of earth. From the surface of earth to 20 kilometers, we called as that region troposphere. From 20 kilometers to 50 kilometers, there is a one layer called second layer. That second layer we called as stratosphere. This stratosphere, which is from 20 kilometers to up to 50 kilometers. Now there is another layer 3. That layer which is from 50 kilometers to 85 kilometers. That layer we called as mesosphere. My dear students, there is another layer, fourth layer. And that fourth layer which is from 85 kilometers to 690 kilometers. That is we get called as thermosphere. Now there is another layer which is from 690 kilometers to 10,000 kilometers. That layer number is 5. We call this one as exosphere. My dear students, here the number 1 and number 4, these two layers are important. The reason is number 1, that layer we can call as a troposphere. In the troposphere only all the aeroplanes which will move. So if the aeroplane which will be cross the troposphere, the pressure will be increases. As a result, aeroplane will be burst. That is why an aeroplane and helicopter never and ever cross the 20 kilometers and it never cross the troposphere and never try to enter stratosphere. Now consider number 1, fourth layer. The fourth layer which is from 85 to 690 kilometers called thermosphere. The thermosphere is approximately 690 kilometers wide. All the satellites, this is a satellite which is projected by the human being called as natural satellites, which is revolve around the earth either vertically or horizontally, either vertically or vertically on the thermosphere only. Above thermosphere, there is one layer I draw here, that is nothing but the ozone layer. This ozone layer is responsible to stop ultraviolet radiation coming from infinity distance into the thermosphere, from thermosphere to the surface of earth. If there is no ozone layer, the earth temperature will be increases. Therefore, there is a layer. Its width is 20 kilometers to 30 kilometers layer. That layer we can call as ozone layer. The ozone layer is above the thermosphere and below the exosphere. that ozone layer OL is responsible to stop the ultraviolet radiation and never send the heat towards the earth's surface. This is about the atmosphere and atmosphere refraction. However, thank you very much for listening this class with full of care. I hope you understood a good concept in this video. Thank you. My dear students, I want to explain a small point. Here, more air is there. Here, more air was there. Here, more air means while coming from up to downward direction, the refractive index is more here. In the first layer, what is more? Refractive index is, we can call as refractive index is more. Please note this point, n is more or refractive index is more. Remaining next concept we can discuss next video. Thank you very much. Thank you very much for watching this video.